Hello, this is Dr. Josh Silver, and I wanted to show you how I am doing a cone beam CT analysis in 3D. And currently I'm using Radiant, and this is a scan from a Viso G7. I have a friend that owns one of these, and I send them to the clinic. And so what we do with this tool is we can assign these different buttons in Radiant by either left or right clicking them. So if I left click this, now left click is shade and I can control shading. If I control right click and on zoom, now zoom is my right click and shading is my left click. Or I can go ahead and put line on right click, and now when I right click I'm drawing measurements. This is my refresh button. And so when we're going to do an analysis, the first thing we need to do is unrotate the scan, because we would never take a rotated x-ray, nor would we take a rotated cone beam. And my favorite way to do this step is to take it over to the side, and we look at the posterior aspect of the TMJ. And so we'll see one here and here, and we're going to make sure that they try to overlap. So right at this point where they overlap, we have a coordinate system in Radiant that says we're at negative 89 degrees of rotation in the scan. This is why I like to use Radiant, is because it tells me where I am. And there's a lot to talk about in this case. She has some conditions, some genetic conditions that cause some malformed discs and fusions, and you'll see quite a bit on this. So I thought it was a good case to share. But when we talk about negative 89 degrees is straight lateral for her, which means that if we subtract 1 degree off of neutral, we actually go to +1. This should, +1. That's 90 degrees off of that negative 89. And so now we should be seeing her straight P to A with no rotation where her jaws are matched up. And for many people, that's going to be a really good way of matching this up. But in traditional methods on x-ray, we would actually be measuring this more quite like this, from that lateral margin of the orbit out here towards the sides of the skull. And so you would say, okay, there's 0.25 degrees or centimeters of rotation. Is this acceptable? We could use the right arrow button on our keyboard to bring her to 0 now on the coordinate system off of that -1 and measure that. Looks quite a bit closer. So pick your poison. In this case, you can see that her jaw is obviously misaligned. So we're going to go with 0 degrees is going to be straight P to A for her, or A to P with no rotation. And keep that in mind as you continue, because you need to know where that is. So we'll refresh the image. And the first thing we need to do is measure her head tilt. And the way we do this is we prepare the image for analysis in Radiant, and then we pull up the toolkit. So for head tilt, all we really need is going to be this section of the skull where we would classically measure. And I'm ready to measure. So my toolkit button is right here, and when I click it, it becomes active. And now that it's active, you'll see this blue bar of tools across the top of this screen. And once it's active, I can no longer control anything on my screen. I can't move it, I can't shade it, because toolkit's active. If I want to be able to assess my image for movement, I can minimize toolkit, and then I can go ahead and start manipulating my image again. But since we're ready for measurement, we're going to open toolkit. And there are ways to measure head tilt. You could use the vertical angle tool to just simply draw a line best you can through the nose, through the middle of the skull, and say, okay, this head tilt looks like it's to the right by 1.8 degrees. You could use a horizontal angle tool on the tops of the orbits, various points on the skull, as many as you choose from, because in cone beam, you have many options. And so this is 1.8, this is 1.8, that's 1.5. I also built a cephalometer tool. When you hit cephalometer, we'll open this bar and we'll place one of them here, and we'll place the top of it on the other side. And we need to rotate this to get a little bit closer, so we'll use this button here at the top. And this really works very similar to how we had it in viztek, where the arrow keys on my keyboard will slide it to the left. I can move it up with those arrow keys, and then the caret keys will rotate it a little bit at a time. So we will box out the skull as best we can, and when we think we've come to a good place with that, we'll hit the enter button, which now says that the head is tilted 1.4 degrees to the right. So once we're ready to record our head tilt, whichever one you choose, we open up the main calculations. And the way we use this is we're going to fill these boxes out from top to bottom very simply. For head tilt, we're going to say it's to the right, and we're going to just say, let's go with 1.5 in this case, because it seems like the most common number there. Two 1.4s and two 1.8s, 1.5s, pretty right there in the middle. And of course, you could measure this a million different ways and get a million different measurements, but we're looking for a general consensus there. Next, we're going to measure the plane line, and I split the plane line up into two parts. We're going to measure the superior lateral mass and the inferior lateral mass. So the reason I prepared that is because in cone beam we can see the anatomy much more clearly. And so instead of using the plane line as we would traditionally we would always measure the plane line off of these points here. First of all, before we do that, notice that there is a gap missing in her posterior arch. And then also notice that the posterior arch here is over the anterior arch. We see the top of the anterior arch here, we see the bottom of it here. Traditionally on our S-line we would have those overlapping. So I'm going to use the arrow keys to position it till those are very nicely overlapping. Now, when we open up the toolkit, why would I measure the misalignment at this joint, C0, C1, based off of where these points are? They have very little relationship to the joints, completely different structures. I feel the same way about this joint, C1 to C2. The marking from the posterior arch could be different than the bottom of that joint. And so what I have done is, because in cone beam we can actually see this much more clearly, is I've broken it up so that when they disagree, as you see in this case, what we're going to do instead is use this measurement against the head tilt to calculate our upper angle, and we're going to use the bottom of the atlas against the cervical spine tilt to measure our lower angle. And that's very complicated. I call it the Josh Silver triple plane line theory. And you can do that as you want with a calculator, or you can stick to traditional methods and just use this one number off of that posterior arch in both of these boxes. So what I'm going to do is I'm going to say that the top of her atlas is high on the right by 4.83 degrees. And the bottom of her atlas is high on the right by 4.73 degrees. And we're going to average those two out to create a working plane line of 4.78 degrees. Now right now we're doing all of the measurements in the EPIC terminology, or the EPIC techniques terminology, but the truth is that all orthogonal techniques have upper angle, lower angle, C over A, and we just have different names for those. So we can switch this wording towards advanced orthogonal, NUCA, or orthospinalogy. I like orthospinalogy because we all understand it. And what we're saying is that if the head is tilted to her right by 1.5 degrees, and her atlas is high on the right by 4.83 degrees, she's going to have an upper angle of 6.33 degrees. Now, we're going to assume right now she has a lower angle of 4.73 degrees because we haven't measured the cervical spine tilt yet. Once we do that, it will recalculate that lower angle for us. So let's go ahead and do that. We will hit minimize on the toolkit, and start to prepare our image for our lower cervical spine angle. Now there are several ways to do this. You can do it from the front or the back. Lately I've liked doing it from the front because you can see the vertebral bodies easier. So we'll use the scalpel tool in Radiant to scalpel off everything in front of the neck. When we hit delete, and we'll bring it back to 0 degrees of rotation. Now this is how we could measure her neck if we wanted, with all of that anteriority she has, or we could actually use the arrow keys to rotate it a little bit. It might be a little bit easier to see at 14 degrees of negative rotation. Let's compare. And so if we prepare this image, we'll just get that contrast as good as we can. And then we'll open up the toolkit and clear all. I've built a center point tool here. And we can change the colors from red, yellow. It's a little bit easier to see some dark colors sometimes. So I'll just go with black. And we'll hit center point. Did it in yellow. Let's try that again. Black. And there we go. We'll center point out the dens. We can center point out the size of C2 if we choose. We can center point C7. So here's C1, 2, 3, 4, 5, 6, 7. We'll center point the vertebral body. And so we can actually see the vertebral body on the anterior view, whereas we can't see it on the posterior view on the three-dimensional rendering. So now we'll use the vertical angle tool, and we can place that right there on the center of the dens, and here on the center of that C7 body, and we'll see that her neck is tilted to the left by 3.74 degrees. Okay, and now that we compare 3.74 degrees to 4.73, we have a lower angle of only 0.99 on that left side, kind of like that. So we can clear all. The next part is our C over A. So let's go ahead and get prepared for measuring a C over A in 3D. And for this, usually I prefer to measure C over A in 2D, but we can do it in 3D if we bring the skull this way to 90. And once again, we're going to use a scalpel tool, and we're going to remove the front of the skull, and we're going to remove just about half the atlas, and just the front of that C1 and C2, and then we'll remove everything in our way. I really enjoy this scalpel tool in Radiant because of this feature. So now we're back to 0 degrees, there's no rotation. What a nice beautiful cut in 3D of the condylar and axial joints. So we're going to get a nice zoom in on that. And this is at 0 degrees. But I like to see where C1, C2 joints really nice and flat. So sometimes I'll play with that tilt a little bit there. Right. And so, yes, it's negative 12, but keep in mind how much head tilt or anterior head carriage she had to get that C2 joint nice, flat, and crisp. And then the last thing we do is we're going to have to drop a measurement tool, just a flat measurement. And now you press the shift button, and it becomes flat. And we should keep it fairly long, just like that, out of the way of the joints. So now we're ready to measure C over A, and we will open up the toolkit. And the first thing we have to do is calibrate the toolkit. We have to teach the toolkit what length is on screen. So it gives us this little line, and we're going to make it the same length as the line we drew, and teach the toolkit that this is 3.55 centimeters long, or centimeters long. Now, very easily, we'll take this C button, and we're going to drop 4 points on the lateral, more weight-bearing parts of this condylar joint. And it will tell us that the diameter of this is 2.37 inches, which is our condylar circle. The axial button here will upload exactly the same way. More of the weight-bearing portion of the joint is how I have been traditionally trained. And our axial circle is 6.77 inches. So we have this nifty button auto load, which will carry those numbers right here into our C over A. Okay. So there we go. I made an error earlier. The head tilt is to the left, so here we have a left head tilt. So the last things we're going to need is atlas rotation and C2 spinous rotation. And to do this in 3D, once again, we need some pretty intricate scalpel maneuvers. So we'll bring this over to 90 degrees. And since we'll be looking from the bottom on this case, we're going to scalpel off everything below the atlas. First thing we do is we're going to scalpel off everything below the atlas. And we're going to come up here and we're going to scalpel off just the bottom or base of the dens. Oh, I made an error. Let me try that again. The base of the dens. And then we're going to spare the C2 spinous, but take the rest of the neck. And delete. Now, when we bring this back to 90, this is very important, is that we already established that 0 degrees was straight A to P with no skull rotation. And if we know that, then any rotation off of that is going to be misalignment. So, it's very easy to do that with the vertical and horizontal angle tools. Let's get that shading just right. And so when we open up the toolkit, here all, first thing I'll do is center point out the middle of that dens. And basically see the very middle of it right there. And then we'll use that vertical angle tool to place it on the middle of the dens, and then the very tip of that C2 spinous. And what we're seeing is that compared to 0, her C2 spinous is kicked off to that left side by 5.6 degrees. And so we'll enter that here as 5.6 degrees of C2 spinous rotation. And what's pretty nifty about this is that I think this is the first time in orthogonal we're measuring C2 rotation in the Y plane off of the Y plane, instead of elaborating how much C2 rotation is occurring based off of a measurement obtained in the frontal plane. And so I think this is a much more accurate measurement of how rotated that C2 is when we're looking at it from the bottom. We'll use the horizontal angle, and we can place it on the back of these joints right here. And it's saying, wow, those are 7.05 degrees anterior on that left side, posterior on the right. And again, you can measure this however you want, in whichever technique you want, off of whichever points you want. But to keep this demonstration simple, I've been trained that the posterior aspect is the best to go with. So the calculator only eats anteriors. We'll tell it that the atlas is anterior on the left side by 7.05 degrees. And with that, we will have all of the measurements necessary to see how her misalignment plays out in orthospinology terminology, epic terminology, advanced orthogonal, etc. So the last thing we're going to start to do then is we'll refresh the image, and let's take it a straight P to A shot, no rotation. That, of course, would be 180 degrees, using our handy nifty coordinate system here. Let's prepare the image, just get as big on screen as possible. Pull up that toolkit. And we have this show misalignment button here. So when you press it, it's going to take your measurements and put them directly on screen like this. So we can drag this plane line down till it's right there. This button here we'll place on the center of her neck on the bottom. Let's see, spinous, why not? And then we'll place this right in the middle of her head. And now you can actually get a really nice classic view of her orthogonal misalignment and get some ideas on how you're going to correct it. So I like to give these to the patient. That's why I have a snip tool here to grab this, and we can go ahead and just save that in downloads. If you want to perhaps grab a lateral for the patient as well, you can do that fairly quickly as well. Now for orthospinology, we have built a calculate button. So hit calculate and you'll have your height factor, your rotation angle, and your RF. If you're in the Epic technique, we have this button Sonus where it will copy your measurements to clipboard and then you can paste them directly into Sonus. One of my favorite and very last things to share about 3D cone beam is we know she's a right laterality and we need to know where her transverse process is. So I've devised this nifty little step where we'll match up the jaws. She had a bit of head tilt. And we can see the TP there and the TMJ there, and the back of the mandible there and the mastoid there. And what we'll do is open up Toolkit, and we're going to use the freehand tool. And I like to have this in like a 3 for this step. And we're just going to trace the mastoid. Whoa. And we'll trace the back of that mandible because we need to know where that is. We'll be palpating for that. And then we'll trace that transverse process, which is right here on this girl. And then we're going to jump back into the gradient and not move a hair, but change the shading till we can see her ear. And when we open up the toolkit again, we can see externally now where her mastoid is, her TMJ is, and her transverse process. And this is quite helpful in determining where to aim the instrument. So we'll snip that as well and save that. You can take here, and if you're save measurements, and now you should have 3 nice pictures of her measurements, her TP location, her lateral, and her misalignment. So, if you are interested in this toolkit, you can scroll to the bottom of the page and I'll provide a live one-on-one training, and I hope this is helpful for you. Thank you.